Hey, welcome back, guys. Welcome to the channel. And the last video we talked about the third type of sort, and yeah, we talked about it, insertion sort. In this one, we'll be talking about the fourth one, the cyclic one, the cyclic sort. We'll be talking about its application and where and when and how it will be used. To be honest, it looks like it's very custom, but all the questions, if asked in interviews about sorting, then they'll be surely about cyclic sort. So yeah, I hope this one's a very important one of the most important ones before obviously merge sort and quick sort. So let's get into it. All right. So cyclic sort. Like before, we'll be talking about what the application is, what cyclic sort is, how it's used, where it's used, and the logic behind cyclic sort. And to be honest, it's not that hard. It's very easy. One of the better ones, to be honest, but also it requires its conditions, specific conditions. All right. So yeah, let's talk about the conditions. Actually, this one. So the four most important condition about cyclic sort to apply cyclic sort is that you should be given a range of numbers yeah. Now this range could be from 0 to n, from 1 to n, either 0 to n or 1 to n, right? So this is four most important. If you see a range of numbers, or if you are given in the question that you are given from 1 to 40 or 1 to 50 or something, anything, then it should click in your mind that if you are going to sort it, then you better use cyclic sort, because this is specifically made for that. So we'll be looking at both the cases, at 0 to n and 1 to n. Nothing much in logic, but let's understand the application and how cyclic sort is actually used. All right. So let's say we are given the array as 10, not 10 actually, because we actually have to take then 10 elements. All right. So we'll be taking 6, 4, 1, 3, 1, 2, 3, 2 and 5. All right. So you are given the range of elements from 1 to 6. All right. So like I said, if you are given a range and you are somehow asked to sort it, or directly you are basically going to sort it, then use cyclic sort. So what is cyclic sort? Cyclic sort basically means that you are placing the elements at its correct index. Now what that means, let's apply the indexes over here. So 6 is at 0th, 4 is at 1, 1 is at 2, 3 is at 3, 2 is at 4 and 5 is at 0, 1, 2, 3, 4, 5. Yeah. So here we can see that 6, let's talk about 6. 6 should be actually at 5th position, 5th index, right? So it should be at the last if you are going to sort it in ascending order. By the way, we will be always using ascending order when we talk about sort. The entire logic can be reversed, simply reversed, if you are doing descending order, right? So that doesn't make any sense if I use ascending or ascending, but yeah, we'll be talking about ascending, so the application gets thorough. So 6 at 0th should be at 5th index, so we want 6 at 5th index. Then we talk about 4. So 4 is currently at 1st index, but we want it at 3rd index. Yeah. Then we talk about 1. 1 is currently at 2nd index, but we want it at 0th index. So we talk about 1 as 0. Then we come to 3. 3 is at 3rd index and we actually want it at 3rd index. So yeah, basically it's at correct position. It should be at 2nd index. Then 2 should be at 1st index, and 5 should be at 4th index. So I hope you can actually spot out the pattern over here, because it's very obvious now that I pointed it out, that 6 should be at 5, 4 should be at 3, 1 should be at 0, 3 should be at 2, 2 should be at 1 and 5 should be at 4. So basically the element, this is the element, should be at element minus 1 position. That is correct, because the index we are starting from 0. So we are basically subtracting 1 because we are starting from 0. So this is basically swapping. So let's say, now let's do a dry run. So when we find 6, we know that what it is correct position. We know that 6 should be at 5 but is at 0. So we simply swap the 0th index with 5th index. So 6 it is at 0th index, and 5th index should be containing something which is 5 at this point. So basically we switch them. So now 6 goes at which index? 5th index, and 5 goes at 0th index. This is for the first element. Then we go for 4, which is at 0th index over here, and it should be at 3rd index. So we simply swap it with the element at the 3rd index. So it's basically very simple, and it's just big O of n. We are doing it in linear time. We will just iterate all the elements at once, one by one, and we find each element, and we simply place it at its correct position. So that's why it's called cyclic sort. So 6 goes at 5, 4 goes at 3, 1 goes at 0, 3 goes at 3, 3 is at 3, 2 should be at 1. This is actually first index, so 2 should be at here, and 5 should be at here. So if you can see all of this mess, if you can somehow understand the pattern over here, it's basically cycling all the elements at its correct index. And yeah, now you can also understand that this will always and only work if you are given a proper range from 1 to n or 0 to n. We'll talk about both. We are talking about 1, from 1 to n, because we started with 1, 2 and 3. That's why we are subtracting 1 here, element minus 1. Simply don't subtract it. If you are over here, we are comparing it with element minus 1. If we simply use from 0 to 6, meaning 7 elements, then we don't need to compare it with element minus 1. We simply compare it with elements index. This is the index and this is the value at that index. So if it doesn't match, then we simply swap it. So it's very simple. Let's write the pseudo code over here, so it'll get more clearer. Basically it's still swapping only, but only you swap if it is not at the correct index. Alright, so let's create the sort function. Alright, so we simply take in the array. That's the only argument that we need to take in consideration. We declare a iteration variable which is going to start from 0. Remember, if you have the array that has the range from 0 to n or 1 to n, that doesn't matter. Your iteration will always start from 0, because indexing of array will always begin from 0. So just a point to clear that out. So int I is equals to 0. Now basically we will iterate. We will be using a while loop for this one. We don't need to always use the for loop. We can use, but just a bit of change. So while I is 0, while I less than array dot length. So for this one I am considering that it is a 1 to natural number range of 1 to natural number. So if so first of all we find the correct correct index. We will also need a correct index. Correct should be the I minus the element of I minus 1. Basically what this line means is that where is our array? Okay, so 6, 4, 1, 3, 2, 5. So what's the correct index of 6? So array of I, which is at 0, so 6th element minus 1, which is 5, that is correct. that for 6 the correct index should be at 5. Yeah, so this basically is that helper. We are finding the correct index for it. That's why we are using the error that element at that index. We are subtracting 1 from it. And if we are using 0 to n, then we simply don't use this minus 1. Alright, so I hope that part was clear. So it's not that hard to understand. Just don't use minus 1 if you are starting from, if the range is from 0. You simply need to subtract 1 because our range is from 1 to n and the indexing starts from 0 to n. So to balance that difference, we are using minus 1 over here. Alright, so correct index, we found the correct index for this element. Now we simply check that if the correct the element actually is at the correct index, which is array of I. What we are basically checking is that this correct index for the 6 should be 5, and we are checking that at the 5th place does 6 exist, means over here, means it should basically match. That's what I'm trying to suggest you. So does this match? If it doesn't, then we simply swap it. Now what do we swap it with? We simply swap this and this. We simply swap the indexes, not the elements. Remember, we are swapping the indexes. So basically we should negate it. So if it is not correct, then we will swap it. So we can create a helper function over here that takes in the array, the index and the correct index. These two will be swapped. Alright, yeah, and if that is not the case, meaning if they are actually correct, if the index and the element actually balances it out, means at the 5th index 6 is actually present, else then we don't need to do anything and we simply need to continue checking onwards. So I plus plus, yeah, and in the end, after this while loop finishes, we can simply return the array, or nothing, to be honest. We can simply print it out if we don't need to return it. And this, by the way, swap function, I hope it's very clear, because I've been using that swap function since last 3 videos in all the bubble sort, selection sort, and recently I did insertion sort. All of those places we use the swap function, so I'm not going to again write it out. So this is the the function for when we are using the range 1 to n. Like I said, if you are using from 0 to n, then we don't need to take in the minus 1 over here. We are simply balancing the 0 index with the first 2 n ranges by using the minus 1 over here. Simply we don't need to. It's just very clear. You can simply even apply the logic over here, that what is array of I and how is it the correct index. Do we need to use minus 1 to balance it to correct index? Do we not need to? So it's very intuitive. You can figure that out yourself as well. Alright, so like I said, cyclic sort, again very important. It will be only used if the array is within a range from 1 to n or 0 to n, right? And yeah, the time complexity. So we're using only one while loop, and each time we iterate the ith element, we'll be checking simply if it is at its correct index. If it is, then we don't need to do anything. We simply iterate forward. If it is not, then we simply swap the correct index with the index where we are in. Alright, so the time complexity over here is simply big O of n, because we don't need to use another loop within a loop for this one. So in a way we can say that it is much more efficient than the previous 3 ones, because all of theirs time complexity was big O of n square. We were using loop within a loop, right? So for this one we are using big O of n, and yeah, for the space complexity will remain nothing, it's constant. because we are not using any extra space. We are simply this is, like I said in the last video, we are iterating from within the same array, so it's in place. This is in place because in the argument you can see that we are actually taking in consideration with the array. So when we call this function sort, like sort, and our array would be something like 6 5 4 3 2 1, then we will be calling this array. We don't need to actually create any other thing or any other data structure to hold in the array variables or anything like that. We'll be calling this array within the sort function only, so it's using constant space. Basically all our previous functions were also using constant space. That will change for the next two ones, because we'll be using recurrence, and we will be using we'll be using extra space, but for that we'll be taking time, right? So yeah, again, the best case and worst case scenarios, all the elements are at its correct index. We cannot say they are at the correct place, we should say that they are at the correct index. They could be at correct place and at correct index, that is correct, but when we explain the best case scenario, then we should say that all the elements from 1 to n are at its correct index. That is the best case scenario. The worst case scenario, we can simply say they are not at its correct place, or simply they are in descending order, or maybe something like that, and that could be literally any number of case other than correct index that makes it the worst case. Maybe the worst case could be everything is going to be swapped, so yeah, all of that. So yeah, that's the cyclic sort. I hope you enjoyed this one. In the next videos we'll be solving some questions about all the previous algorithms that we learned about, which means all the searching and sorting videos. I'll make a combined video based on sorting and searching, where specifically I'll be covering binary search and cyclic sort, because there is like a literally 99% chance that if you are asked a searching question, that it would somehow relate to binary search, and if you are asked to take in a sorting question, then it would be like 99, not 99, because there is merge sort and all related, but there is a very good chance that cyclic sort is to be used in that application. So yeah, I'll be covering that part in the next one. So yeah, thank you. I hope you enjoyed the video. Like, share and subscribe. Alright, thank you.